Engineering. Today I'm going to introduce you to my favorite scanner for leak repair purposes, the Artec Leo. This scanner is great for leak repair because it's fully wireless, which means that you don't have cords to worry about or trip on when you're in the field. You don't have to bring a laptop with you. It has a built-in battery which lasts for many hours, so you can capture all the data you need in the area of repair. Another thing that's really nice about it is it has a touch screen on the back, which operates very similar to an Android or an iPhone, so it's very easy to use and to train people on how to use it. And one of the last things that I really like about this is that it doesn't require targets or markers to be put on the pipe like other 3D scanning technologies, so therefore you can scan on hot objects or cold objects, because nothing's actually physically touching the pipe or the object that you're scanning. So what I want to do is I want to show you how the scanner will capture this valve in real time. Probably take me a couple minutes, and then I'll show you what that 3D scan data looks like and how we use it to engineer repair. So on my screen, you will see a projection of what I'm seeing on the screen of the Leo. So right now this is just warming up, and you'll see that we've got the object, the valve, appears on the screen in front of me, and this gives me real-time feedback if I'm in the right operating range or if I have captured enough data. So I'm going to just start scanning right now. So I'm going to work my way around this valve. I'm going to go capture it from a few different angles. You can kind of see the valve is building in real time as I go around. So I'm going to simulate here doing a bonnet repair. So with square bonnets, they're notoriously difficult to measure. And so here, I'm going to just stop and take a look at what I've captured. So on the screen, I'm just using my fingers to rotate the valve around and actually check to see if I captured everything that I want. So this is very handy to do this prior to leaving site. So if I was doing a valve bonnet clamp or a bonnet clamp, I would want to make sure that I see green all the way around that bonnet surface, which I do see here. So in this case, I would be happy with this scan and be ready to leave site and transfer it to the computer. So what I'll do is I'm going to pause this recording. I'm going to transfer the data, which will take a couple minutes, and then I'll show you what it looks like when it's on my computer screen. So I transferred the data from the Leo scanner to the computer, which usually takes about a couple of minutes, and then this is what you'll see on your screen using the Artec Studio software. So I've got the valve in front of me. What you can do then in Artec Studio is you can delete any extraneous data. So if you have captured something you don't want, you can very easily delete it. If you have multiple scans, you can align those together, and then you can merge that all into what we call a mesh file. And so by running an algorithm in here, I'll show you what this looks like once it is meshed. So this one has color on it. I'm going to show you what it looks like without that. So this is a mesh file. So we use this for taking measurements, as many measurements as we want, in order to do our engineering design. So one cool thing about 3D scan data is I can pick points anywhere on this surface. Let's go from here across to here, and you can get that exact measurement. I could do another one. I can go from here to here if I want the thickness of the bonnet. Essentially, if I want the length of the valve, I can go from here to here. So anywhere you want to get measurements, you can very easily click and find the distance between 2 points with very high accuracy. So you don't really have to worry about going back to the field and remeasuring. But one of the most powerful features of 3D scan data, and something we use all the time for designing leak repair enclosures, is what's called a cross-section. So let's say we were doing a valve, a bonnet clamp here. So these bonnets have many different angles and radiuses, and they're very hard to measure in the field, and often the measurements aren't perfect. So what we can do is we can take a cross section where I pick a couple of points here, and that will project a plane, and then I can drag this cross section anywhere along the valve and find out the exact profile of the valve in that area. So what I'll do is I'll just calculate this. So that will be called section 3. Now, save that. So with section 3, this is essentially the two-dimensional profile of that valve bonnet. So when we're designing from this, we can take that line and ever so slightly just expand it to make our bore clearance on our enclosure so that it fits on there perfect. Just a slight little offset. So you can do that in any direction. So this whole process here, from me to scan the valve, import the valve, and get cross-sectional measurements, took about 10 to 15 minutes. And then when we take that and we do our engineering design, you know that your clamp is going to fit perfectly. So another really nice thing too is that we know a lot of the time in leak repair or any repair situation, sometimes the client requests changes, so they might want something else. They might change their mind and say, we actually want to enclose the whole valve, or we need strong backing or something like that. And so because we captured all the data, we can change course without having to go back to site. So that's another really nice thing. So there's not really much more to talk about other than to show you the color features of this particular Leo scanner. While it's not required for engineering, it is very, very handy because technicians can make markings on the pipe that they can use to communicate with us things like direction. So they could mark on here a little arrow to say this direction is north, or put little markings on the studs, 1, 2, 3, to communicate which stud they're talking about, and it just makes that communication process really seamless. So that's pretty much it for this demo. If you have any questions, feel free to reach out and we'll get you some more information.